Okay, so we'll have a look at it and then you have a go and I'll try to help out. Parametric. Any ideas already? Salaam? Any thoughts? How do we generally find dy by dx when it comes to parametrics?
I haven't really gone over
I
this.
just vaguely remember. I thought one of our last lessons was about parametrics. Yeah. Okay, so when you to find dy by dx, it's dy by dt.
Oh yeah.
Yeah. Dx by dt, because we know when you divide it flips that fraction upside down, it cancels blah blah, and you get
Yeah.
dy by dx. Okay, so at least we've got a plan now, so have a go at doing the bits. So why don't you try and lead me through this? What's the first thing we're going to do to work out dy by dx? We need to know dy by dt. What's that going to equal? So you got y equals 2 tan t. Okay, now you might be thinking, oh my, well, I'm not sure if you're thinking this, but tan t, that doesn't sound like a very nice thing to differentiate. But it is. The good news is it's in the C3 part of your formula book. Yeah?
Oh.
So it's just sec squared t. Yeah?
Okay. Yeah.
So basically, sticking, you know when you got a 2 in the front or some number in the front, you can just ignore it, yeah, and you put it back at the end. So basically it's 2 sec squared t. Yeah, it's one of those things you should be comfortable with doing, yeah? So
Yeah.
2, so anyway, so 2 sec squared t, what we're going to do next?
Differentiate the x.
Cool, so we got x equals sine squared t. Now that's not straightforward. Is it straightforward? Yeah, it is actually.
2
Yeah.
cos t.
Okay, so what we're doing, we've got sine t. I'm going to write it this way around, like that, to remind ourselves what's really happening. Because that means the same thing, right? 2 sine squared t is that. So differentiating a function of a function, you do that first, and then times by the differential of the inside. Differentiate the outside times, and then you got the cos t going on. Good. Okay, so it's 2 sine t cos t. And obviously, since we said we're going to divide it, we're going to put it underneath. So you got 2 sine t cos t. Okay. So we basically got the answer, but you kind of get the feeling that you should be simplifying it, and that's one obvious thing to do, isn't it? Cancel the t's. Sec squared t. And sine t cos t looks really familiar, so I'm not going to spend too much time on it because they didn't. I don't know if you're necessarily going to have it simplifying, but sine t, 2 sine t cos t looks really familiar by itself though, so I kind of feel like I shouldn't have cancelled it. But any ideas? No, I think that's going to go wrong because 2 sine t cos t. Do you recognize it as sine 2t?
Yeah.
Yeah, but that's not really helpful, I don't think.
Yeah.
And sec squared t is related to 1 and tan squared and all that, but that's not going to be helpful either. So forget it. Yeah, cool. We'll just leave it as that stuff there. Sec squared t over sine t cos t, whatever. And part B, the tangent to C of our curve. Where's C? There we go. C is the original graph. At point t equals 3, cuts the x-axis at P, find P basically. So we've got, it's always good to imagine what's going on. There's funky graph, we've got no idea. Oh, actually it's not like that, because it only crosses at one point. So let's make funky graph look like that. Okay, and that is P. I like to imagine it like that. So we've got that, and we've got our function, this is the graph, and yeah, so what we're going to do now, how are we going to find out the position of P?
Find the gradient.
Find the gradient? Nope. Okay, so we know it cuts the x-axis at P. When you cut the x-axis, what do you know? What numbers do you know? What fact in terms of numbers do you know?
Y equals 0.
Y equals 0. Okay, so we know when t equals pi over 3, y equals 0. Come on, tell me more. What's that? Connect the two facts. Connect the two facts. T equals pi over 3, y equals 0. Can you see it yet? What's the equation?
Would you use the previous equation?
Which gun? What previous equation?
In part A.
Yeah, you're probably saying this. Are you saying that?
Yeah, that. Yeah.
Cool. Okay, so we're saying 2 tan t equals 0 when this. I'm gonna write that again because you need to write tan t, because we're gonna replace that t, isn't it? T is what?
Pi over 3.
Pi over 3. So let's get rid of that and put pi over 3. Okay. So actually, is that really what I wanted? What does that tell me? I'm not sure if it tells me anything actually. Tangent. I'm kind of thinking that I'm making it more complicated than it needs to. Cuts the x-axis. So it's cutting the x-axis there. You know what? I'm kind of making it. That doesn't tell you anything, I don't think. Does that tell me anything? Because I'm just thinking maybe I should have just put it straight into here and I would have got the x value. I don't know why I'm probably overcomplicating it. Does that make sense? We should just put it in that one. X equals whatever. Because we know it crosses. We don't need to show anything like it crosses the y-axis. Yeah. So even math teachers can go the wrong way, and I think that's a really important thing to learn, because sometimes as students you think everything's got to be perfect. It's like, just relax, just do it, and you'll make some silly mistake for a second and go, hang on a minute, why am I doing that? Because sometimes you go into silly mistake because you're thinking about some other kind of question.
Yeah.
And some of the questions are a lot easier than you think. So you stick t equals, so we just need the x position. We know it crosses the x-axis. We don't need to prove that it crosses the x-axis, which is kind of what I was doing before. So sine squared pi over 3. Now we've got to figure that out. What does that equal? How are you going to figure it out? And I want to do it without a calculator, because it's a good practice to do stuff without a calculator. It's not making it hard for actually maybe kind of gives you a better idea what's happening. So sine pi over 3. If you're like me, I convert stuff into degrees, because I might, degrees what we started off with, right, when we were learning maths. So pi over 3, what angle is that?
Um, 60.
60, yeah. You always have to remember, you know the quadrant stuff, that is pi, so cutting into 3, that's going to be, 180 divided by 3 gives you 60, cool. So that is pi over 3. Why am I drawing this triangle? Do you remember this triangle? Do you know what this triangle is? That's the 30 degrees. What length is over there? What length is your hypotenuse? I mean, not your hypotenuse. Yeah, hypotenuse as well, but I mean opposite. Do you remember this triangle? Very important triangle.
Is it the root
Root.
2 one?
Yeah, but it's root 3. Okay. Root 2 is the other one. 1, 1, right angle.
Yeah.
Root 2. But I kind of memorize it because I've done it so many times. But I've done the working out so many times. I go, there was an equilateral triangle that got cut in half, and equilateral triangles all have the same length, and in this story they all have 2, and I know it's got to be 2 because I'm going to cut it in half and make it 1.
Yeah.
So all the bits remind you of what it should be happening. So obviously when you cut it in half it becomes a right angle triangle, and every angle is 60. That has got to be 30. Do a bit of Pythagoras. This squared gives you 4. That squared gives you 1. 4 take away 1 is 3, square root it. That kind of story. Yeah? Not too hard. Don't memorize in the beginning. Just keep remembering the story behind it, and eventually you'll memorize it automatically, because otherwise you're going to go crazy in the exam. You're going to be panicking in the exam, and you're going to do rubbish in the exam. Yeah, you need to be relaxed when you go in there. Okay, so what does, from this triangle that we've just drawn, okay, what does sine pi over 3 equal? Sine pi over 3. Okay, what is this
root
number?
3 over 2.
Yes, root 3 over 2. Cool. So, what don't we have to work out sine squared first? Isn't it sine squared times pi over 3?
When you square
No, I'm
pi,
messing around with you. Okay, sorry, go on.
pi over 3 over 2 square.
So, root 3 over 2 is what sine pi over 3 is, and then you square it, isn't it? Yeah?
Yeah.
And what does that equal?
3 over 4.
Cool, we got the answer. That is the x coordinate of p, as easy as that. Yeah?
But
Have I missed something out? I could have.
no, I'm just thinking it's like 6 marks, so,
Yeah, you're right. 6 marks, that looks too easy. The tangent to C... that's not good. That is really being lazy on my part. The tangent to C... Oh, gosh. Okay. Here we go. So... have you realised, like I've realised, what I've been doing, completely being silly?
no, not yet.
So there's a tangent to C crosses, not the C itself.
Oh, okay.
This is just so lazy of me. Okay, so I was wondering, it just felt too easy. Anyway, even if it was less than 6 marks, it just felt too easy. Tangent to C at P crosses when T equals 3. What? Okay, so I'm still reading it wrong. The T equals pi over 3 is where... Okay, I have to read it slowly. The tangent to C at point where T equals 3 cuts the x-axis at the point P. The tangent to C at the point where T equals pi over 3 cuts the x-axis. I'm still the tangent to C at the point where T cuts the x-axis of the point P. Okay, yes, that is right. The drawing is right. Now it's right anyway. find the x-coordinate of P. Find the x-coordinate of P. So over here, t equals pi over 3.
Yep. Would you substitute in the part A?
Yeah, because I think in part A we worked out dy by dx. Yes,
Yeah.
we did. Okay, so we have to substitute it into this thing. So we get the gradient, and then we get the equation of the line and find out where that straight line crosses at P. Finally, whoa, that was long. Okay, so let's see how quickly we can finish this off. So t into pi, so t into this, pi over 3 into that, gives you, what is that going to be? Sec squared. Let's focus on that. So sec squared pi over 3. How are you going to work that out? I suppose you could stick it in a calculator, but how would you do it without a calculator? Because it gives you better understanding what's happening if you...
1 over 1.
Yeah, so it's basically 1 over cos pi over 3, and then you square the answer.
Yep.
So cos pi over 3, let's go back to our picture or our triangle here. What is cos pi over 3? We know that's 1, by the way. What is cos pi over 3? So pi over 3 is there. Did you say it already? You haven't said it, have you? No.
Yeah.
What is it?
Half.
Half, that's it. So that's a good number, because this stuff is half. What's 1 divided by half?
2.
2. So it's 2 squared, which is 4.
4.
Cool. So the top bit is a nice number. Now it kind of tells you you're on the right path. Sine t cos t. So we know what cos t is. Cos pi over 3, that's half. We just said it. And sine is the same thing as root 3 over 2. We said that earlier on. So that's just equal to root 3 over
4.
4. And so we had to do root 3 over 4 divided by 4. Is that it? No, it's the other way around. See, I'm being really lazy. I don't know what's wrong with me right now. Maybe I'm slipping or something. But does that make sense?
Yeah.
Because that was the sec squared biz or whatever. So how do you do that? That looks really, really good. Because can you see what's going to happen? Was it equal?
Root 3.
Yeah, kind of. Okay, so let's write it like this. 4 over 1 divided by root 3 over 4. So that's not what I was thinking it was going to be. So it equals, you know, you turn this upside down and times it, so 16 over root 3. I thought it was going to cancel. That doesn't sound right. So sec squared is one on the top, and so that was on the top, and that was on the bottom. So I've done it right this time. I'm second guessing myself a lot now because I've been writing really silly stuff for a bit. But anyway, whatever. That's the answer.
So is that the answer to the...
Well, actually, yeah. What is that the answer to? That is just telling you the gradient, isn't it?
Yeah.
Gosh, really. Don't know what I'm doing today. I'm being really lazy. I think it's because of this flu. It's really distracting me. So we got this what's it called, gradient, which is that funky number there, 16 over root 3, and find the x coordinate. So what do you have to do next?
Find, well, y is 0, so find
well,
x
we haven't even got the equation on the line yet. This line, remember?
Yeah.
So we got y equals 16 over root 3x plus c. And we also know a coordinate. We kind of know. We don't know it yet. We know when a point on this y equal this straight line is, when t equals pi over 3. So we can work out what, we can work out what x is. Well, let me rub out these. We can work out what x is and what y is, at t equals pi over 3.
Yeah.
Yeah, and then whatever, so t equals pi over 3, we know that sine t, okay, I'm going to cut off, and actually I'll give the,
Isn't it time as well?
yeah, exactly, so I'm going to cut off now, and maybe we'll continue afterwards, but pick up some more questions, yeah?
Yeah,
Yeah, okay, Assalamu alaikum.
Alright,